Hey, all you Gretas and Shutezcats out there. Welcome to Chapter 3, Section 3, What Happens to Energy in an Ecosystem. So, energy flows through ecosystems through movement between both trophic levels, through food chains and food webs. And understand that the quality of energy available to organisms is going to decrease as each successive trophic level is reached because so much energy or heat is lost moving from one energy to the next. Now, we talked about in the last chapter that energy isn't lost, it's just converted to a less useful form. So when it's converted to heat, it heats the organism and then it goes into the environment. So it's no longer available to be passed on to that next level. So we can have a food chain, and you guys are the grass is eaten by the bug, is eaten by the bird, is eaten by the cat, is eaten by the fox. One thing is eaten by another thing. So this is a sequence of organisms, each of which serves as a nutritional source for the next. 90% of your energy is lost as these organisms convert the chemical energy from food energy to the energy needed to live and grow. So just like last chapter when we talked about this, only 10% of that energy consumed is available to make up that organism and is passed on to the next food level. So food chains are nice and pretty, but they're not very accurate. Food webs are a complex network of interconnected food chains, and this is much more accurate to what you would find in nature and ecosystems. So a food chain, the sun sends its energy to the plants or the producers, and we lose energy as heat, lower quality energy. The producers are eaten by the primary consumers, and once again, heat is being given off. Primary is eaten by secondary, secondary is eaten by tertiary. Any point in this food chain when something dies, it's being broken down, and all of the nutrients are being returned. But the energy flow, notice the energy is going to, the arrows are pointing to the thing that is getting the energy. So if this was a hamburger and this was you, the energy goes from the hamburger to you. So that's the way that the arrow is going to be pointing. So make sure when you're drawing one of these that you have the arrows pointing in the correct direction. So a food web is way more complex. So here we have our phytoplankton, which is our version of plants in the ocean that are eaten by herbivorous zooplankton and krill that are then eaten by carnivorous zooplankton, squid, fish, petrels, different birds and mammals, and then humans are way up here at the top. But notice that depending on how you go through these, you can be on different levels. So we have first, second, third, fourth, fifth, sixth. We usually don't go up that many. Or you could do first, second, third, fourth. So you can be on different trophic levels depending on what path you take. So keep that in mind. But this is much more accurate to what is actually happening in an ecosystem. We will be challenging you guys this week to make your own food webs. Energy flow, most of the energy, once again, is in your producers. Then your primary consumers have 10% of that. Your secondary consumers have 10% of that. And your tertiary consumers have less than 10%, have 10% of that. Now, you can't go too much further than tertiary because so much energy is being lost. There's not much left by the time you get up there. So we usually stop at tertiary. Sometimes we have a quaternary, but usually tertiary is where we stop. Once again, decomposers break down everything because they always win, and heat is being given off everywhere. Just remember all that spilled rice from the activity last week. Primary productivity. We have two types, gross primary productivity and net primary productivity. Gross is everything. So when you get your paycheck, you have your gross pay. This is everything that you have made due to your hourly wage. So this is the rate at which an ecosystem's producers converts radiant energy into chemical energy. So how well do plants in that ecosystem turn energy from the sun into sugar to be consumed? That's it. Net primary productivity is the rate at which they use photosynthesis to produce and store chemical energy minus anything they need to do to use energy for themselves. So plants make their own food, but they do need to eat some of that. It's not all available to us. So that would be your net primary productivity. What is available to others? So gross is how much energy, how much chemical energy do plants make? And net primary productivity is how much is available for that next food level. Measure at the rate at which producers make chemical energy potentially available to consumers. So when you are looking at the net primary productivity of an area, you would say, okay, what is available to that next level? Ecosystems very much vary in their net primary productivity. So despite having a very low net primary productivity, the oceans take up such a large part of this planet that they produce most of the world's biomass. So it may not seem like it, but the oceans do make most of our biomass just because there's so much ocean out there. Tropical rainforests tend to have high net primary productivity due to how many different kinds and how many plants that they have. Only plant matter that is represented by the net primary productivity is available for nutrients as nutrients for consumers. So the planet's net primary productivity ultimately is going to limit the number of consumers that can survive. So there's a magic number of animals and species that can be supported by this planet due to our planet's net primary productivity. Nice and quick and easy, and we're done with section 3 of notes. So before I go, I want to remind each and every one of you that you are good enough, you are smart enough, and that people like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.